Here we have a complex circuit, 12 volt battery, a 2 ohm resistor, 6 ohm resistor, a 3 ohm and a 1 ohm resistor over on the right hand side. We are supposed to find out what is the voltage, resistance, and current at each part of the circuit. So first thing we have to do is we have to combine our resistors to get an equivalent resistance. That's always the first step. So we look for any resistors that we can combine first in series. To be combined in series means that you can draw a line through the two resistors, and the only thing in between the two resistors is a wire, no junctions. So resistor 1 and 2 are not in series because there is a junction in between them. Likewise, resistors 1 and 3 are not in series because there is a junction in between them. However, we see that resistors 3 and 4 are in series. The only thing in between them is a straight wire, no junctions. And so we're going to first combine resistors 3 and 4. Now the combined resistance is going to be simply adding the two resistors together. So 3 ohms plus 1 ohm. We want to redraw this circuit. So we have our battery, which is 12 volts. And the first resistor is our 2 ohm resistor. And we still have over here a 6 ohm resistor. And we've combined resistors 3 and 4 into a single resistor, which is 4 ohms. You want to make sure you draw these intermediate steps, because as we work backwards, we're going to write our information on these diagrams. And you also want to make sure you draw your diagrams large enough so we can fit all the information on there. So we are not done combining resistors yet. We notice here that we still have a combination of series and parallel. They're not all in series, nor are they all in parallel. So the next resistors we are going to combine is resistor 6 and resistor 4 here. We notice that they are in parallel because their tops connect and their bottoms connect with nothing but wire in between. So again, in order to be in parallel, the tops and bottoms have to connect with nothing but wires in between. And so we find the equivalent resistance, and the equivalent resistance, 1 over the equivalent I should say, is 1 over 6 plus 1 over 4. Common denominator is 12, and we end up with 5 12s. But that's not the equivalent resistance. Remember, we have to flip this, and so the equivalent is 12 fifths, which comes out to be 2.4 ohms. I'm at this point going to move from fractions to decimal points, because the fractions will get a little sketchy as we continue on. So again, we want to redraw this circuit combining the 6 and the 4 ohm resistor. So we have our 12 volt battery. Up here we still have our 2 ohm resistor. And now we've combined the 6 ohm and the 4 ohm to get 2.4 ohms. Now we know how to solve for this circuit. We've done circuits like this before where there's two resistors in series. And so the first thing we do is we solve for the equivalent resistance. We have a 2 and a 4 ohm resistor, and so the equivalent resistance is simply adding those together. And we come out to get 4.4 ohms. Once you know 2 out of the 3 values at any spot, you can solve for the third using Ohm's law, which is V equals I times R. So here we have a 12 volt battery. We're solving for the current, and the equivalent resistance is 4.4 ohms. And so we get the current comes out to be 2.73 amperes. Now in a series circuit, you ask yourself, are the currents or voltages the same? And it's the currents that are the same. So because the battery is 2.73 amperes, this is also 2.73 amperes, and this is also 2.73 amperes. Once again, once you know 2 out of the 3 values, you solve for the third using Ohm's law, V equals I times R. So the voltage at the 2 ohm resistor is the current, which is 2.73 amperes, times the resistance, which is 2 ohms. And so we get that voltage to come out to be 5.45 volts. Next, we solve for the voltage at the 2.4 ohm resistor. So again, Ohm's law, V equals I times R. So 2.73 times 2.4 ohms. And we get the voltage to be 6.55 volts. We can check our work, add those two values that we just calculated, 5.45 plus 5.55. And that does indeed equal 12 volts. So again, whichever value you calculate, whichever value is not the same, add them together. It should equal whatever it is at the battery if done correctly. So now we work backwards. And as we work backwards, the battery and the 2 ohm resistor do not change. So this is still 4.4 ohms and 2.73 amperes. This is still 2.73 amperes and 5.45 volts. However, this single resistor now turns into 2 in parallel. And so in a parallel circuit, it is the voltages that are the same. So this voltage of 6.55 is the same as the voltage of this one, 6.55, and this one, 6.55. So again, as we work backwards now, don't skip the step of drawing the intermediate schematic drawings. Don't skip that step, because as we work backwards, we need to write the information on those schematic drawings to get to our original schematic. So as we work backwards, we ask, are the currents or voltages the same? If it splits into 2 in parallel, the voltages are the same. And once you know 2 out of the 3, we solve for the third using Ohm's law. So again, Ohm's law is V equals I times R. And so for the 6 ohm resistor, we have the voltage of 6.55 volts, and we're solving for the current. The resistance is 6 ohms. And so we get the current to be 1.09 amperes. For the 4 ohm resistor, again 6.55 volts is equal to the current times 4 ohms. And we get the current comes out to be 1.64 amperes. To check our work, we add the two values we just calculated together. 1.09 plus 1.64 equals 2.73, which is what it was when they were combined together, 2.73. So now we work back to our original schematic drawing, and the battery does not change, so we know that the equivalent resistance is still 4.4 ohms. The current at the battery is still 2.73 amperes. So we already knew that. Resistor 1 did not change from what it was in the previous diagram, so the current in resistor 1 is still 2.73 amperes, and the voltage in the first resistor is still 5.45 volts. The 6 ohm resistor, resistor 2 did not change, so we still have that the voltage is 6.55 volts, and the current is still 1.09 amperes. However, this very last step, we see that this 4 ohm resistor gets split into two in series. So this single resistor gets split into 2 in series. So in a series circuit, it's the currents that are the same. So the current of this one, as we work backwards, is the same as the current in each of these. So the current in resistor 3 is also 1.64 amperes, and resistor 4 also has a current of 1.64 amperes. Once you know 2 out of the 3, you solve for the third using Ohm's law. So V equals I times R. So our voltage is 1.64 amperes times 3 ohms. And the voltage comes out to be 4.91 volts. Make sure you draw your schematic drawings large enough so you can write all this information on them. And voltage 4, I times R, so again 1.64 amperes times 1 ohm, and voltage 4 comes out to be 1.64 volts, same as the current. Now again, check your work, whichever value you just calculated, add them together. 4.91 plus 1.64 comes out to be 6.55, which is what it was before. So there you go. Just make sure you draw all those steps in between. Draw all those circuits, and so that you can work backwards as you solve for all the values.